Dear all, good evening. I am back with my webinar series number 21, this time on testings of EHV circuit breaker. We know very well that circuit breaker is the device which, with the help of protection relay, help us to isolate the faulty part of power system during any abnormal condition. It is the only device which works in all three conditions: no load, full load, short circuit, or even any abnormal conditions sensed by any protection relay provided by utility. It is in fact a mechanical device with some operating mechanism operated by closing and tripping coils in the circuit breaker, having fixed and moving contacts, some arc quenching medium, etc. Now, it is very important to think about the safety and the health of this protective device who protect us against any abnormal faults. And some tests are mandated to be conducted as per the recommendations of OEM and some relevant IS and IEC. To know more, or in fact in depth about the testings, I'm happy I am with very special guest who is the master of testing expert of scope, pioneer in the testing equipments. He is respected Mandar Tarade. Before I give a brief introduction about my presenter and invite him for presentation, I always do with a thanksgiving. And from the core of my heart, I would like to thank my family, my mentor, my supporters, my friends. In that list, first of all, I would like to say thanks to Almighty, my family, my parents, wife, and my son. My mentors include respected PP Bhai sir, Anjali Chandra ma'am, KK Murthy sir, NK Mittal sir, P Ramachandran sir, S. Apau sir, Hitesh Chauhan ji, Dr. Kamar Bansal sir. In the list of my friends and well-wishers, the names comes with the Saket Gupta, Arvind Thukral ji, Dinesh Singh ji, SK Batra ji, Vishen Dutt ji. Last but not the least, my team working day and night 24/7 for making this webinar to happen includes Ramdhani and Gulab. And very special thanks to Gulab for taking pain 24/7 to make this show to happen. Now time to give introduction about the presenter, Mandar Tarade. He is with the scope, the pioneer in testing equipment for the last 16 years. Has experience of manufacturing, quality, customer support, and product specialist department. Presently, he is heading PS department and he has exceptionally good experience related to circuit breaker, transformer, and lightning arrestor. Last but not the least, he loves to do R&D and he has been instrumental in the development of product range of scope. Now, without further ado, I would like to hand over to Mandar sir to start his presentation and make this stage on fire with his knowledge he has. Welcome, sir.
Thank you, sir. Thank you very much, sir. I hope I'm audible.
Yes.
Before starting the presentation, I must say thanks to Rajesh Arora, sir, for giving us the opportunity to share our views as well as the experiences, whatever we have gained during the entire testing of the EHV circuit breaker. We are very much thankful that, and I must say that you are doing such a great exercise through the medium of the Igniting Power Engineers group. You are actually educating the people or bringing the engineer to such a level that he or she become the independent executioner during the testing of different duties which are available in the live switchyard or the substation. So this is really great exercise, sir, what you are doing. I must appreciate and really hats off to you, to your exercise, to your entire team who is taking the 24/7 efforts to make this exercise or to do this exercise successful. And this is really a great thing and really great opportunity for me as a Scopian to present and share our knowledge, whatever is available with us, because as a leading manufacturer, we are taking many efforts to develop these kits. So this is the exercise, or this is the, so without taking much of the time or without saying anything, I will just share my screen and will start the presentation. Do I?
Welcome. Please share your screen and start your presentation.
Yes, sir. Yes, sir. Sir, my screen sharing is disabled actually.
Gulab, allow him to share. Is it working right now?
I will check. Not yet, sir.
Gulab, kindly help, sir.
Yes, sir. Yes, sir. I'm doing same. Sir, kindly check.
Not yet, sir.
Just a second, sir. Just a second. Stop video pin, remove spotlight. Sir, you can allow him.
Yeah, thank you. But still the messages appearing on my screen is host disabled participant screen sharing.
Rajesh sir can allow him.
Okay, let me do. You can make him host automatically. He will be able to share.
Yeah, yes, sir.
Kindly check now.
Not yet, sir.
Gulab, what happened?
सर सर को पहले होस्ट बनाना पड़ेगा. जब सर होस्ट बन जाएंगे देन और होस्ट आप बना सकते हो.
Or sir, you may share. There is no issue as such. That means, or else.
Now check.
सर नो, अभी तक होस्ट का साइन नहीं आया इनके पास. ये अभी इनके ऑप्शन में जाके आप इनको मेक होस्ट करेंगे तो ये होस्ट बन जाएंगे. हाँ, अब आप कर सकते
हैं. Is my screen visible to all?
Yes,
yeah,
yes.
yes,
Please,
yes.
I have done it.
Okay, okay. Yes, sir.
Please start. Welcome again.
Just a minute, sir.
Make it full screen, sir.
Yes, sir. It's not happening actually. It's coming as a full screen, sir, or yet?
No.
Is it visible now, sir?
Yeah,
No?
visible, but not full screen. Make it full screen.
Participants can now see your screen, but it is not. I'm making it, sir, but it is not going as a full screen video.
No issue. You can start.
Okay, sir. Yeah. Anyone of you giving us the opportunity to share our views and experiences. From bottom of my heart and from the entire Scope technical team, I welcome all of you. As Rajesh sir has already briefed that. Sorry, just a minute, sir. But it is not. Yes, it is changing. Actually, Rajesh sir already briefed that what is the purpose of the circuit breaker. That means the today's topic is basically the testing of the circuit breaker. What is the testing of the circuit breaker? Why the testing of the circuit breaker is important? Before that, actually, once again, just highlight that. I would like to highlight that. That means whenever we want to make or break the circuits, we are using the circuit breaker. Earlier to the circuit breaker, the people were using the fuse, but the restoration in the fuse is not possible. Why? Because once there is a fault, then in that case, fuse may get blow. Okay, so that the restoration is not possible. And if you require to make and break the higher circuit voltages, then in that case, the formation of the arc and the quenching of the arc plays the significant and the important role. That's why the circuit breaker comes into the picture. The operation of the circuit breaker is basically divided into the two categories. First one is the manual and second one is the automatic. In case of manual, wherever we want to perform the diagnostic or health assessment of the different duties which are available in the substation or the switchyard, there at that time actually we are isolating the circuits with the help of the circuit breaker. And second thing is that the automatic type of the circuit breaker, where actually with the help of the relay we are assessing the fault condition, or depending on the algorithm route in the relay we are assessing the fault condition, and if the fault is there, then in that case the entire substation, we are just stopping that fault with the help of the circuit breaker. The relay immediately triggers the circuit breaker, and accordingly circuit breaker will get stripped. Okay, so these are the basically two operation mediums of the circuit breaker. Then depending on the arc quenching medium, there are four basic types of the circuit breaker. First one is the air circuit breaker. Second one is the oil. Third one is the vacuum, and fourth one is the SF6. SF6 is nothing but the sulfur hexafluoride. Nowadays, very popular in the market is the sulfur hexafluoride, type of the CB, because of the arc quenching as well as the cooling mechanism of the sulfur as well as the dielectric strength of the sulfur hexafluoride gas is really good. Okay. So just moving further, in today's topic, what we are going to cover is the testing of the EHV CB. Why the testing of this EHV CB is important? What different tests we are going to perform on the EHV CB. Okay. Then next one is that what is the significance of this different test what we are performing on the CB. Then further moving to that, what is the purpose and use of the DCRM? Why we require to perform the DCRM operation? How we can able to do the proper and signature analysis of the DCRM, from which we can able to identify or we can able to comment on the health of the contacts which are not visible to us. Then we will also cover the case studies of the DCRM. Now, as per the IC standard 62271, the circuit breaker testing is divided into the three categories basically. First one is the testing of the interrupter. Second one is the testing of the driving mechanism, and third one is the testing of the control unit. Sir, my screen is visible to all, no?
Please continue. Hello? You should not worry. Please continue, sir.
Yeah. Thank you, sir. So according to this IC standard 62271-100, the circuit breaker testing is divided into the three categories. In that, first one is the testing of the interrupter. Then second one is the testing of the driving mechanism, and third one is the testing of the control unit. In case of the testing of the interrupter, what test we are performing on the interrupting mechanism, interrupting contacts, is first one is the contact resistance. Contact resistance measurement of the, that means whenever we are performing the contact resistance test, we are getting the idea about the healthiness of our static contacts. Second important test, in case of static contact resistance test, we are keeping our interrupter in the closed condition and we are injecting the known amount of the current through the contacts, where all the fingers are intact and your breaker is in the steady position. At that time, whatever the resistance value we are getting gives us the impression about or the idea about the health of our static contact. Next one is the DCRM test. DCRM test. In case of DCRM test, basically we are performing the dual operation, that is the CO operation or the dynamic operation, And in that, according to the duty cycle defined by the IEC standard, we are giving the delay TCO for the mechanism, and accordingly we are performing the DCRM test and checking the behavior of the arcing contact as well as the main contact. Moving further, we are performing the timing test. With the help of timing test, we can able to check whether whatever result we are getting are as per the standard or as per the limits of the manufacturer or not. Next test is the wipe of the contact. With the help of travel traces, we can able to, or with the help of the travel traces and timing references, we can able to get the wipe of the contacts. The next one is the dew point, the standard dew point. That means we are using the sulfur hexafluoride as a arc quenching medium. Okay, so the dew point plays the significant role. As per the standard, the dew point value must be in the range of -60°C to -6. The next one is the fault current, arc time, etc. Moving further, we are also performing the test on the driving mechanism. Driving mechanism plays the significant role, and with the help of the driving mechanism, by placing the transducer on the driving mechanism, we can able to calculate the total travel of the mechanism. Second thing is that we can able to calculate the default velocity of the mechanism, which is very much important. Then we can also able to calculate the datum velocity or the average velocity of the mechanism. Also, we can able to calculate the healthiness of the damping mechanism. So these are the tests which what we are conducting or performing on the driving mechanism. Further moving ahead, we are performing the test on the testing of the control unit. In control unit, basically we are performing the test on the coil current and the auxiliary switches. As all of us knows that to energize the coil is basically used to actuate the mechanism. Okay, and the auxiliary contacts are always connected in series with the coil for the protection purpose. So with the help of by the way of performing the test on the control unit, we can able to comment on the health of the auxiliary contact as well as the coil current. Moving ahead, before performing the test, actually we need to understand that why we require to perform the test. That means in the beginning itself, I have highlighted that we are for the assessment of the health of the DUT, we are particularly performing all these tests. That means these tests are very much important to assess the health of the DUT, and from that we can able to comment that whether our DUT is healthy or not. If it is healthy, we can able to charge the DUT. If not, then in that case, we need to do the preventive maintenance of the DUT or the maintenance of the DUT. So by assessing the contacts quality, with the help of this CRM, we can able to assess the contact quality. Second thing is that means we are supposed to check the contact resistance of the breaker. In case of the EHV circuit breaker, the static contact resistance of the main contact is basically in the range of 32 to 40 micro ohm. If because of any X reason, if your contact resistance goes on increasing, as the resistance is the passive component, if there is an increase in the resistance value, then in that case, the power loss is nothing but I square R. If there is an increase in the resistance value, then definitely it will goes on increasing the losses, and it will increase the temperatures too. Okay, and because of that, it will create the cascading effect. To avoid the cascading effect, we need to assess the health of the static contacts. And with the help of this CRM value, we are getting the idea about the early that means we are getting the idea about the developments of the faults. If there is a significant rise in the specific value of the contact resistance, so as per the standard, the contact resistance value should not exceed beyond the 100 micro ohm. If it is exceeding beyond that limit, then in that case, we need to take the corrective action. So with the help of this, we can able to identify the things. Again, on my screen, it is clearly visible that because of the increase in the contact resistance value and the temperature, which are directly proportional to the energy E, because E is nothing but R multiplied by I square RT. R is the resistance of the contact, and the I square I is the current passing through the contact, and T is the duration. Okay. So in that case, particularly with increase in the R value, creates the more losses and more temperature rise, resulting in the degradation in the contacts. That's why CRM test plays the significant role. Actually, the CRM is very basic test. That means, suppose that if we want to know any unknown resistance value, what we are doing, we require to pass the known amount of the current through the unknown resistance value, and simply with the help of multimeter, we can able to take the, or we have to take the drop across the unknown resistance value. Okay, so with the help of Ohm's law, we can able to calculate V is equal to I into R, or R is equal to V by I, whereas V is the drop of the voltmeter, or the drop across the DUT, which is under test, and the I is the actual current passing through the contact, or the DUT current. Okay, but after looking from the outside, the contact resistance test is very simple, looks like very simple, because see, the known current source is available with us, the unknown resistance is available with us. If we are simply placing the multimeter, or if we are simply placing the voltmeter across the DUT, we can able to simply calculate the unknown resistance value V by the way of V by I. Okay, but please remain present to the fact we are performing the entire testing in the live switcher. And whenever we are placing, which is surrounded with the induction, so whenever we are placing the cable, or whenever we are connecting the cable to our DUT, which is actually the 14 meter, which is on the almost 14 meter height from the ground potential, from the ground. So whenever we are placing the cable across the DUT or across the contacts, then in that case, your cables gets charged. Okay. And suppose that if your resistance value is 40 micron and you are injecting minimum 50 ampere of current as per this IC standard 62271-100 or ANSI standard C37.09, then in that case, suppose that if your value is only 40 micron and you are injecting the known amount of current that is 50 ampere, then in that case, you are getting only a drop of 2 millivolt. And if you are increasing the current of 100 ampere, then in that case, you are getting the drop of 4 millivolt. You have supposed to bring that drop from the top position of the 14 meter height to the ground where we are placing our equipments and doing all the signal conditioning. Here, the cable plays the significant role. And according to that, the measurement methodologies, there are basically 3 measurement methodologies. First one is the 2-wire method, second one is the 3-wire method, and third one is the 4-wire method. The important thing is that where you are, in case of 2-wire method, the same cable, what we are using for the injection of the current are used for the taking the voltage drop across the DUT. But this method is not so much accurate because the lead resistance is not eliminated or compensated in this method. The classic example of this method is the multimeter, where actually with the help of two cable, we can able to, and the battery, we can able to simply test the unknown resistance. But here, one thing just I want to highlight is that here your resistance value must be significantly on higher side. If your resistance is in kilo ohm, then in that case, with the help of this, you can able to get the value of the resistance. Second thing is that the 3-wire measurement practice, actually 3-wire measurement practice, here we are using the two current injection cable, on only one cable is used as a voltage pickup. The classic example of the 3-wire measurement method is the earth resistance measurement method or the Venner's method, where with the help of this, you can able to measure the resistance which is in few ohm. Okay, which is in few ohm actually. This measurement method is comparatively accurate than the 2-wire measurement method. But the most precise and accurate measurement method is basically the Kelvin's 4-wire method, where actually 2 separate cables are used for the injection of the current and 2 separate cables are used for the measurement of the resistance. So with the help of this method, we can able to precisely measure the resistance value, which is in the micro ohm or milliohm. So whatever test we are performing on the DUT, in most of the tests, we are performing the test with the Kelvin's 4-wire measurement method. This is very important. That's why the cable plays very significant and important role in this measurement. I hope this is clear to all. Moving ahead, the timing test on the CB. Why we require to perform the timing test? As per the IC standard, the different timing tests we are performing on the CB. But why the timing test is required? is required, because actually timing test is used to compare the circuit breaker's contact performance against the manufacturer specification. So whether you are getting the contact timing in well within the specified limits or not, even with the help of the software, you can able to do the trend analysis of your timing. And if it is exceeding the limits, then in that case, you need to set right the timings. According to the IC standard 62271-100, we are performing the different tests we are performing the different timing test on the CB. Likewise, first one is the close, second one is the open, third one is the CO, that is the close open, then the OC, open close. OCO is basically used to perform the auto reclosure or to check the auto reclosure mechanism. And if you are having the multi-shot, that is for the single shot auto reclosure mechanism. And if you are having the multi-shot auto reclosure mechanism, then in that case, we are performing the OCO test, where we are performing the test O 300 millisecond CO, then 3 minutes CO. And accordingly, we are checking the health of the contact timing or the health of the timing. Simply in case of the close, we are simply simulating the close on the live circuit, or in case of trip, we are simulating the short circuit trip. Here, the important thing is that the CO, here the delay TCO plays the significant role, because our expectation is that it simulates the trip on the short circuit after close. So to perform the immediate tripping, our expectation is that once the auxiliary changeover happens, our trip command should be available there itself. It should not wait further. Okay. So the thumb rule is that your delay TCO at the time of performing the CO operation must be close timing minus 10 milliseconds. This is very important and plays very significant role at the time of performing the CO operation. The next test is it's an OC test, that is the open close test. It is basically used to simulate the fast close after short circuit trip. Many people are not performing the OC test at the time of doing the health assessment or the diagnostic test of the CB. Then the OCO test. OCO test is basically the health of whether your auto reclosure mechanism is working satisfactorily or not. Apart from that, there is one more test, is called as the PDR test, where we are performing the test, or we are checking whether the PDR, pole discrepancy relay, is operating satisfactorily or not. Okay, so these are some of the tests which we are performing as a timing test on the CB. Moving further, the coil current measurement test. As all of us knows that what is the purpose of the coil? The coil is basically used to actuate the mechanism. Once the coil, what we are doing, actually we are extending the positive DC. Always the negative is available at the one side of the coil. And whenever required, we are extending the positive to the coil through the auxiliary switches, basically. Okay, so the purpose of the coil is to actuate the mechanism. Once the coil is energized, it basically hits the plunger and the mechanism will start moving, and latch will get released and mechanism will start moving. That is the basic purpose of the coil. So if my screen is visible, here I have particularly highlighted 6 points, where the first point is the energization of the coil. Second point is the plunger begins to move. Third point is that there is the again decrease in the current of the coil, where the plunger hits the puffer. Next one is the coil reaches to the maximum current value, or the reach the saturation of that, and after that immediately auxiliary switch gets changeover. Okay, and the coil current reaches to 0. As all of you know that auxiliary switches are basically the gang operated switches, and it is basically used to protect the CB from the false command. Because suppose that your CB is in the closed condition, then at that time your auxiliary switch of your closed circuit is in the open condition, and the auxiliary switch of the open circuit must be in the closed condition. So the next allowable command to your CB, will be the open. Okay, and it will ensure that none of the false command, or not even any single false command, will go to the CB. Next, the travel measurement for the CB. This is very important. Actually, with the help of travel measurement, actually, even in my consecutive slides, you will get the better idea about the travel measurement, because with the help of travel measurement, we can able to comment on the different parameters like the total travel, what is the contact wipe, what is the contact gap, what is the rebounds, what is the over travel, or what is the archic contact tip length. These are some of the parameters which we can able to identify with the help of the travel measurement of the CB. Here, the travel measurement is nothing but it is the indication of the instantaneous position of the CB during operation. Here, if you see on my screen, I have taken the cognizance of the timing graph where actually the change in the contact is there at that time. First touch from the 0 to first touch is nothing but your contact gap. Then if you are moving further, that is the value of your contact gap. It is there in my consecutive slides. Then moving further from that point, first touch to the travel stabilization point, the delta between these two, the travel delta between these two is nothing but your contact vibe. And the summation of the contact gap plus contact vibe will give you the idea about the total travel of this CB. If you are placing the cursor at the 0th position where your mechanism is steady, where your mechanism is idle, there is no movement in the mechanism, and the second position where your mechanism is rested after performing the operation. So the delta between these 2 points will give you the idea about the total travel. I'll just repeat the things. Here we are taking the cognizance or we are taking the reference of the first contact touch. So from the 0th position to first contact touch point will give you the idea about the contact gap. From the first contact touch to the travel rest or the travel stabilization or the mechanism stabilization, that delta will gives you the value of your contact vibe. And from the beginning, from the 0th where your travel or the mechanism is idle or the no movement is there, and the second where your mechanism is rested completely, the delta between these two will gives you the idea about your total travel values. Okay. Also here 10 milliseconds prior to your first touch is the first point and the first touch point. The slope between these 2 points will gives you the value of the datum velocity at the time of closure. And in case of tripping, it is exactly reverse of that, because whenever we are performing the tripping operation, the first point is the first tripping point and the 10 milliseconds after tripping. So the slope between these 2 points will gives you the idea about what is the default velocity at the time of tripping. So this is about the default velocity. So the parameters what we are getting with the help of these travel traces are, first one is the total travel, second one is basically the contact travel, third one is the contact vibe, fourth one is the over travel, fifth one is the rebound, sixth one is the default velocity, and seventh one is the basically datum velocity. Datum velocity is basically the average velocity or the velocity between the any 2 random points where we want to measure the velocity. Normally, as per the practice or the thumb rule, we are performing this datum velocity or we are taking the datum velocity between the 20% and the 80% of the travel, where we are getting the velocity is called as the datum velocity. I hope this point is clear to all, because this is very important important parameters associated with the travel measurement. One important thing I want to highlight here is that whenever we are performing the travel test, at that time, we need to keep in mind that we are placing the transducer. Transducer is basically a device which is converting the one form of energy into the another form. That means one form of the parameter into the suitable electrical quantity. So whenever we are placing the transducer on the mechanism, that placement should be proper. At that time, the electrical stroke length value, what we require to feed at the time of doing the calculation, plays the significant role, because we are equating that electrical stroke length value to the applied voltage. Because see, here basically we are applying the 5 voltage from any instrument, or 5 to 24 volt from any instrument, and resistive element or the transducer which is basically the resistive element, that voltage is coming across that. So whenever we are performing the close or open operation, accordingly we are getting the change in the resistance value and we are getting the appropriate drop. So whenever we are calculating that delta, we are equating that 5 volt to the electrical stroke length, and the delta is equating to the unknown travel, then in that case, we are getting the value of the unknown travel. I forgot to mention one point is that in case of timing, basically timing is the voltage test where we are applying the voltage to the one contact of the CB, to the one side of the CB, and we are sensing on the another side. So basically this is the voltage application method where we are applying the voltage and sensing the potential at the second point of the switch. Okay. So if the switch is in the closed condition, then in that case we are getting the logic 0. If switch is in the open condition, then in that case we are getting the logic 1 signal. Okay. And with the help of this, we can able to calculate the timing, and we are displaying that timing on the display. And accordingly, you are getting the different timing parameters like the close, open, CO, OC, OCO. Okay. Next thing is that the coil current. In case of coil current, we know that if we want to know any coil current, then in that case, we simply require to place the simple ammeter in series with the simple ammeter, or the low value shunt or the low value resistance in series with the coil. So the current, whatever passing through the coil, same current will pass through the low value shunt, and it will even not disturb the current. So with the help of that, we can able to measure the unknown current which is passing through our coil. Third thing is that travel, which I already explained you. We are placing the transducer resistive element on our mechanism, and according to the change in the mechanism or position of the mechanism during the make and break of the circuit breaker, we are calculating or we are getting the travel test, and accordingly we are doing the analysis of that travel test. Moving ahead, actually just have a look of the circuit breaker motion. There are the fixed contact. Next one is the moving contact. Linkages are there. Operating rod is there. Mechanism is there. Latch is there, and stored energy is there. As all of us knows that the energy stored in the medium is rapidly delivered for moving the CB contacts. Correct. And it is very important that the linkages are also plays the significant role, because whenever your mechanisms are moving, accordingly the linkages are moving and they are making and breaking the contacts, because you are from the instrument, you are directly getting the mechanism travel. But if you require to calculate the contact travel, then in that case, linkage ratio plays very significant role, because the contact travel is nothing but the mechanism travel multiplied by the linkage ratio. So at the time of performing the travel operation, the feeding of the linkage ratio is very much important to get the exact contact travel. So two things are very, very important at the time of performing the travel operation. First one is the electrical stroke length, which is anyway available on all the transducers which are used to perform the travel operation for the CB, because according to the mechanism, there are several types of the transducer which are available, because from manufacturer to manufacturer the mechanisms are changed, and accordingly the transducer are also changed. Okay, so the electrical stroke lengths are always mentioned on the transducer. So at the time of feeding the data, or at the time of before performing the operation, at the time of preparing the setup, we need to feed the electrical stroke length, as well as we need to feed the linkage ratio. If we are properly feeding the electrical stroke length, then in that case we will properly get the value of the mechanism travel. We will properly get that means the total travel. We will also, if we are feeding properly the linkage ratio, then in that case you will get the proper value of the contact travel. If any one of you or anyone in the industry is not aware about the linkage ratio, then it's my sincere request to all of you, simply place the 1 as a linkage ratio and perform the travel operation. And after getting the travel traces, if you come across, if you get the value of the linkage ratio, then in that case you can able to feed the linkage ratio, and accordingly you can able to get the exact contact travel, or it can able to calculate the contact travel value. Moving ahead, actually the dynamic contact resistance test. This is very, very important test. Actually, with the help of this test, which is basically the non-invasive test. Why it is non-invasive? Because without opening, without breaking, without breaking means without opening, we are performing the test, and with the help of which we can able to identify there is any pitting, there is any contact erosion, there is any carbon deposition at the contact level, that we can able to identify with the help of this dynamic contact resistance test. So this test plays very significant and important role. Actually, before telling you the measurement principle of the DCRM, let me tell you that what is the need of the DCRM. DCRM signature with the travel traces will give you the fair idea about the healthiness of the main as well as the arcing contact. It will also tells you about the abnormal wear and tear of the excessive pitting or the excessive pitting of the contact. Certain mechanical weaknesses also we can able to identify or undetected, which are undetected by the travel measurements, are simply reflected in the DCRM measurement. It will also give you the prior indication of deterioration of operating mechanism linkages. That's why DCRM. One more important thing is that with the help of software, if you are having the data from the breaker installation or breaker commissioning to the till date data, that means enough samples are available with you, you can simply able to compare the signatures of the DCRM with the old signature, and with the help of that you can able to comment on the healthiness of your contact. So this is about the DCRM test. Okay. I have already told you that if you want to perform the DCRM test, simple, just like our CRM, we must have the known current source. We need to inject the current, but here your CV is not in the closed condition. Here you are, and all the fingers are not completely intact. That is happening at the time of performing the CRM test. Here you are performing the two operation. Here important thing is that at the time of preparing the setup or performing the DCRM operation is that the requirement of the 10 kilohertz sampling frequency. We need to set the sampling frequency equal to 10 kilohertz. Second important parameter which we need to set is delay TCO equal to 300 millisecond. I have particularly highlighted that at the time of performing the timing operation, your delay TCO should be equal to close time minus 10 millisecond. In case of DCRM, we are saying that, or according to the thumb rule or according to the duty cycle, what we have defined, what is defined in the IC 62271-100, your duty cycle is 300 millisecond. So we are keeping delay TCO equal to 300 millisecond. Now, people may think that why the requirement of the 10 kilohertz sampling frequency. In simple words, I can say that higher is the sampling frequency, better will be the resolution, because it will reduces your step size. Also, in terms of the CB terminologies, whenever you are performing the DCRM operation or dual operation, then whenever there is a sudden change or the current transfer from main contact to arcing contact, there is a sudden or drastic increase in the resistance value. Because if you see during commissioning itself, our static contact resistance value is around 32 to 40 micron, whereas our arcing contact value is around 500 to 550 micro ohm. So there is a sudden or drastic change in the resistance value, and it is reaching to the peak within that in the span of 0.2 to 0.3 seconds, which is very small. That's why the 10 kc or 10 kilohertz sampling speed is required. Why? Again, one more thing is that how it is giving the significance or how it is fulfilling the requirement. T is equal to simply 1 by F. So if you are doing T is equal to 1 divided by 10K, will give you the step resolution or step size of 0.1 millisecond. So with the help of which you can able to capture this drastic change in the resistance or the drastic change in the signatures in the during the transition from the main contact to arcing contacts. That's why the sampling speed, 10 kilohertz sampling speed is very much important. Apart from that, whenever contact trouble is there, to record the trouble measurement with the resolution of 1 mm, we require the sampling speed equal to 10 kc. So this is very important to keep the sampling speed equal to 10 kc and delay TCO at the time of performing the DCRM operation. It must be equal to 300 milliseconds. Please remain present to the fact at the time of performing the DCRM test, our delay TCO must be equal to 300 milliseconds. At the time of performing the timing test, where we are again performing the CO operation only, at that time, your delay TCO must be equal to your close time minus 10 milliseconds. I hope this point is clear to all. This is just the graphical representation which is available on your screen. Here, your first arcing context at the time of engaging, first your arcing context touches, then your main context touches. At the time of closing, first your arcing contact comes into the picture, it queens the arc. Then your main contact touches and establish the context. At the time of tripping, first your main contact releases and then your arcing contact releases. And accordingly, we are getting the behavior of the, or we are getting the graph or the plot of the DCRM. Okay. Here, timing trace as well as the arcing contact as well as the main context, I have given the graphical representation. Now, this is actually the CB analyzer, Hijack Ultima and DCRM Ultima is one of the solution which is with the help of which you can effectively able to assess the health or comment on the health of your circuit breaker. Because the important parameter, what we require to monitor is that first one is the contact resistance, second one is the dynamic contact resistance, third one is the coil current, fourth one is the travel traces, fifth one is the station DC or PR resistance value or PR timings. Likewise, you can able to monitor with the help of this kit. Now, these are some of the precautions what we require to perform. We require to take at the time of the performing the DCRM operation. But actually, we are running short of the time, so we will not go in the detail. Actually, what precaution we need to take at the time of performing the test. Instead of that, I will just tell you the what important setting we require to do at the time of doing this performing this DCRM test and the travel test on the DUT, and we will then switch to the DCRM signature analysis, which is actually very interesting topic. First thing is that actually here in your screen it is visible that you need to feed the breaker information, and if you are pressing the yes, then in that case there you need to set right that what is the linkage ratio of your CB. Also, you need to set right, you need to feed the value with the reference of which you need to calculate the default velocity. According to the thumb rule or the industrial rule or the rule or the data what we have received from the different manufacturers, they are basically taking the reference of the timing. That means the first touch point and 10 millisecond prior to the first touch, they are calculating the slope between these 2 points and they are showing the default velocity. Moving ahead, actually, here you will get the references. First, that means close time reference, then the open time reference. Actually, whenever we are performing the close operation, many bounces are coming into the picture. Some people are willing to see the bounces, some are not willing to see. So here, if you are changing the reference as a first closure or last closure, according to that, you are getting the reflection on your timing. Then according to the linkage ratio, what we are feeding here, you are getting the contact travel, because contact travel is again equal to mechanism travel multiplied by the linkage ratio. Okay, so whatever data we are feeding here, with the help of that data, we are getting the value on our, we are getting the results on our screen. These are some of the important settings which we need to follow at the time of performing the DCRM test. I have already told you that what is the significance of the sampling speed equal to 10 kc. Second important setting is that what is the delay TCO, why we require to feed the delay TCO equal to 300 milliseconds. And third important thing is that the plot length equal to 400 milliseconds. Why it is 400 milliseconds? Because we are offering the delay equal to 300 milliseconds. And suppose that in case of spring mechanism or spring pneumatic mechanism, or pneumatic mechanism, your maximum tripping time is around 15 to 30 milliseconds. So in that case, your plot should get the enough plot length to get the entire DCRM signature. Moving ahead, this I already told you that about the electrical stroke length. Hello? Somebody want to say something?
Yes, sir, you are audible.
Yes, sir.
Okay. Yeah.
So please continue, sir.
So please continue.
Yeah. I already highlighted that why feeding the electrical stroke length is important in case, irrespective of any instrument you are using for health assessment of the circuit breaker, the placement of the transducer, likewise the placement of the transducer, feeding of the electrical stroke length and the linkage ratio, as well as the velocity point are very, very, very important. By taking the reference of this point only, any instrument in the world is doing the calculation, entire calculation, and accordingly you are getting the mechanism travel, contact travel, default velocity, and the return velocity. So feeding important points or setting right the parameters plays very significant and the important role. Now moving further, DCRM signature analysis. This is very important, and with the help of the DCRM signature analysis, I just want to repeat once again what parameter we can able to analyze with the help of DCRM is first basically the value of the resistances or the variation in the value of the resistances at the time of making and breaking. That is the arcing contact as well as the main contact. That is the first thing, making and breaking of the arcing as well as the main contact. Second thing is that we are getting the value of the total travel. Third thing is that we are getting the value of the contact gap. Fourth thing is that we are getting the value of the contact Y. And fifth and the important thing is that we are getting the arcing contact tip length. As all of us knows that at the time of arcing, tremendous amount of heat is generated at that point, and because of that your contacts may get deteriorate or damaged. To avoid or to overcome from that, the contacts are made up of, the contacts are coated with the tungsten alloy or the chromium alloy, which are basically having the higher temperature coefficient, and it will save your contacts. So on your screen, the typical DCRM signature is there. Here with the green color, we have indicated the resistance curve, and with the blue color, we have indicated the current curve, which is passing through your DUT and the resistance of your arcing as well as the main contact. Here with the help of the red color, we are indicating or we are giving the travel traces and the coil current. Okay. In case of coil current, actually for the R phase or the cumulative, depending on the connection, how you are making, if you are taking the combined coil current, that is the summation of the C1 plus C2 plus C3, that is the closed coil, or the tripping coil C1 plus C2 plus C3, you are getting the summation of the coil current on your screen. Total travel, at the time of explaining you need to place the cursor where your mechanism is steady, where your mechanism is idle. There is no movement in the mechanism, or your coil energization just begins. Once your plunger hits, the mechanism will start, latch will get released and mechanism will start moving. The first point is where your mechanism is at 0th position. So we are keeping our cursor at first position there. And second, where your mechanism is completely steady. So the delta between these 2 points, which will gives you the idea of your total travel. Is this thing is clear? I hope this thing is clear to all of you. The first point, reference point, where your travel is totally 0, and second point where your travel is completely rested, mechanism is completely rested and there is no movement in the mechanism. So the delta between these 2 points which will gives you the idea of your total travel. Moving ahead to the second parameter is the contact gap. Whenever we need to assess or we need to check what is the contact gap value, we need to keep first cursor as it is, and we need to shift the second cursor to the first contact touches point, or where the current starts building. When the current will start building, just whenever your arcing contact touches, your current will start flowing. So the delta between the zero travel position to the first contact touch point will gives you the value of the contact gap. Okay. Moving to the next point is the contact wipe. Contact wipe is very important parameter. You need to keep the first contact touching point as it is, and second point is nothing but the mechanism rested point or the travel stabilization point. The delta between these 2 points, which will gives you the idea of the contact wipe. Again, one more important thing is that the total travel is nothing but the contact gap plus contact wipe. So with the help of this, you can able to cross-check the things. I hope this is clear to all. This is very important actually. DCRM signature is very important. Many times what happens is that with the help of different set of instrument, we are performing the CRM, we are performing the DCRM, we are performing the timing test, or the whatever diagnostic test we require to perform, we are performing with the help of different set of instrument, not only with the help of scope, with the help of any instrument, we are performing the test. But sometimes we cannot able to properly identify or properly understand the signature or the results what we are getting from this instrument. So these are some of the signature with, or these are some of the points which we are analyzing with the help of this DCRM signature. Next point is that arcing contact tip length. I already told you that contact tip is coated with the tungsten alloy or the is made up of the tungsten alloy or the chromium alloy, which is having the high temperature coefficient. Okay. So whenever you are calculating the arcing contact tip length, first you require to keep the first cursor at the sudden change in the resistance point, and second cursor where your current going down to the zero. The delta between these 2 points is nothing but the arcing contact tip length. Why? Because at the time of releasing, your main contact releases first, and then your arcing contacts will get releases. Okay? So with the help of this DCRM signature, you are getting the idea about the contact travel, contact gap, contact wipe, arcing contact tip length. If you are keeping the cursor on the steady position, then at that time you are getting the value of your static contact. And if you are keeping, one more important thing which I want to highlight here is that if you require to do the arcing contact analysis, it's my sincere and humble request to all of you that we need to do the arcing contact analysis at the time of tripping. Why? Because at the time of closing, we observed the number of bounces and we cannot able to properly comment on the arcing contact or the health of the arcing contact. Whereas in case of tripping, we are taking out the energy or we are taking out the entire energy. So at the time of tripping, we are not expecting any bounces. So at the time of tripping, if we are doing the analysis of the arcing contact, then that will gives you the correct insights or the correct value or correct the significance of the arcing contact. Okay? Sir, do we have some time? Actually, it's 6:10 already.
Yes, you can take 5 more minutes to talk about the case study. That is very important.
Yes, yes. Thank you very much, sir. Thanks for allowing
sure.
me the time.
Please continue. Please continue.
Thank you, sir. Thank you, sir. Yeah. So this is actually the performing test. That means depending on the number of the channels and depending on the number of the breaks available on your CB. Suppose that if it is below 220 kV, then we are having the 3 breaks: R pull, Y pull, B pull, having the individual break or the single break. And if you are having the 400 kV, then in that case, each pull is having the 2 breaks. Okay. And accordingly, we are doing the analysis. In case of 765 kV, each pull is having the 4 breaks. And accordingly, we are doing the analysis or we are taking the signatures. Here on the screen, it is visible to you that here we are doing the coil analysis with the help of C1, C2, C3. We are analyzing or checking the health of the coil current of individual coil, closed coil. Because see, whenever we are performing the coil current operation on the CB, this is the combined test actually. Whenever we are performing the coil current test on the CB, we are getting the maximum coil current. We are having the station DC available with us. So at that time, with the help of Ohm's law, that is R is equal to V by I, we can able to calculate the resistance value of the coil, and which is actually the specified by the manufacturer, whether we are getting the coil current value within the limit or not. Accordingly, we can able to comment on the health of the coil current. Also, we are to comment on the health of the coil current. We are performing the insulation test also. This is basically the successful test. We have received all the 3 coil currents for the closing, all the 3 coil currents for the tripping. One more distinguished, just I want to give you that many people, or sometime at the time of performing the test or during preparing the setup, people may think that delay TCO is delay between the close to open. It's not like that. Delay TCO is always between the delay or the time from where your close command initiated, is the time from the 0th instant to where you are issuing the trip command. That is the delay TCO. So here you have already received all the 3 traces of the trip coil current for the R pole, Y pole, and D pole. Individual breaks are also available. So according to that, the graph is in front of your screen. Now, I already told you that we are performing entire testing in the live switcher. So whenever you are getting the sinusoidal wave, particularly on your resistance curve, then in that case, we need to understand here is that the 50 Hertz noise is coupled on your signature. At that time, what important thing is that we need to just take one wrap, or we need to wrap the cable around the interrupter. Why? Because we are performing, or we are preparing the low pass filter. If the low frequency, that is the 50 Hertz signal, is coming, then in that case, with the help of this, just simple one wrap, we can able to just eliminate that noise, because from the height of 14 meter or 12 meter, we are bringing that signal to ground. So it is possible that the 50 Hertz noise will get coupled. But we don't want the 50 Hertz coupling noise. We want the signature as smooth as possible. Because see, whenever after successful closure of your CB, you are issuing the trip command from time instance 0 to 300 millisecond. So after auxiliary changeover, we are removing the positive supply of your coil. And once your mechanism is completely stabilized, we are not expecting any change in the behavior of your static contacts. But still, in spite of that, if you are getting the behavioral changes, that is because of the noise coupling. That is because of the external conditional noise. Maybe it is a low frequency noise or the high frequency noise. If it is a low frequency noise, then in that case, you need to just take a one wrap. This is the first thing. If it is a high frequency noise, then you need to cross check. Either you can earth the breaker from the both side, or you can just remove one earth. Accordingly, you can able to eliminate the high frequency noise also. Now here, the high resistance graph. Here actually the high resistance graph coming because of there may be the several reasons. First thing is that your contact is not healthy. Second thing is that your cable, which is used for injection of the current, or which is used for the taking the voltage drop, is not healthy. Your channels are not properly working, or your signal conditioning circuit, which is available in the analyzer, is not working properly. Or fifth thing is important thing is that the person who is making the connection on the CB is make the connection, instead of making the connection on the flange, he has made the connection on the loop, or on the jumper, or on the conductor. Okay. Or in case of 400 kV, maybe he has connected the cable to your PR contacts. That is maybe one of the reasons. So please remain present to the fact, whenever you are getting the high resistance value, first we need to cross check that whether we have cleaned the flange with the polish paper to get the proper contacts of the C clamp. unless we are making the proper contacts, you will not get the proper value of the, you are not getting the proper value of the resistance. Second thing is that you need to ensure the health of the test lead set also, because with the help of which you can able to perform the you can able to comment on the resistance value. If your resistance value still on the higher side in spite of all these things, then in that case you need to compare this DCRM resistance value with the static contact resistance value. If both the values are on higher side, then in that case you need to discuss with the original equipment manufacturer and take their opinion on the values. Third thing is that if you are just interchanging the connection of the travel, then in that case, you are getting the reverse graph. If your graph is reverse, then in that case, the values what we are getting with the help of the travel traces, that is the total travel, contact travel or mechanism travel, will get hamper. Will get hamper because of that. Okay. So correct connection of the travel transducer plays the very important role. Now, one more important thing is that in many cases, people get the zero touch on the DC. People are getting the zero touch on the resistance curve. That is the probable reason for the zero touch is that your current is not healthy. You are not injecting the full current, or your source is not delivering the proper current. That's why you are getting the zero touch, or your test lead set is not healthy. That's why you are getting the zero touch value. Moving on.
What is zero touch?
Sorry?
What is zero touch?
Zero touch is actually
kindly let him finish, sir. Kindly let him finish. Then we will discuss. Please don't interrupt.
Yeah. Thank you, sir. Okay, sir. Then now moving further, actually here if you see, here this is the classic case study. Actually here if you see, here your arcing contacts won't get stabilized and it will not gives you the correct behavior of the arcing contacts. During analysis or the diagnostics or the preventive maintenance, we came to know that key moving contacts was found T-shaped and has expanded. Also apart from that, one of the counterhead screw of the moving contacts assembly found loose, and because of that, it affects the results. Here, I will just give you the picture that here, if you see the, it is visible on your screen. No?
Yes, sir.
The contacts is already D-shaped, and because of that, there is a change in the resistance value of your arcing contacts, and it is on significantly higher side. So with the help of this DCRM tool, you can able to comment on your arcing contact as well as the main contact. Also, one more important thing is that I have particularly highlighted that one counterhead screw of the moving main contact assembly was found loose, and because of that, you see here scratches on the moving contact. If you see, the scratches are clearly visible on the moving contacts. Here, the scratches are clearly visible on the moving contacts. This is because of the, and this is, we can able to identify because of the DCRM. So there is one, two, three more slides actually related to the removing of the contacts or the do's and don'ts. I'm also having the frequently asked question during testing or the during the presentation of the screen, but we are running short of the time. So with the due permission or the prior permission of the Aurora sir, we'll move to the next topic, that is the question and answer session.
Okay, and thank you very much for this enlightening session and mind-blowing session from your side. You have done a wonderful job. You have shared your experience, whatever you had. And now, before I invite some questions, you can take the rest of 5 minutes. And I would like to invite S. Pauser, kindly unmute and say a few words as a feedback.
Yes.
Good evening, Rajesh ji. First of all, I would like to thank you, and I would like to appreciate for your consistent service to our nation.
Thank you.
By inviting such experts. across various fields to sensitize the electrical engineers. Another thing, I would like to congratulate you for being conferred as a member in ET20, an important sessional committee for the safety of, for enforcing safety. I am confident that you would be doing more service in this session. Especially in today's session, I think presented by expert Mr. Mandar, it's a very good an enthralling session, I can see. He is strong in testing and measurement protocol. I should appreciate you, Mr. Mandar, for this health check on circuit breakers, because circuit breakers are, especially EHV circuit breakers, they play a vital role, a crucial role in the grid supply management and protection. So its healthiness shall always remains as an important parameter. So he has almost explained everything like an ECG for the person to be monitored frequently for the equipment also. Because the grid dynamics are changing due to the ever-increasing harmonics injection into the grid, and there will always be some unforeseen things because of SBR ratio and other things. The circuit breakers are susceptible to be affected by many factors. So it's the right time that people should realize that signature analysis has to be understood. And I would like to request Mr. Rajesh Arora, it's a very good, in my mind, I would like to mention as an important point here is, you are having a lot of experts like Mandar and other people in your series of webinars. Why don't you connect those people for undertaking some interactive or such R&D job? For example, here, what I have learned, learning is a continuous process, as Rajesh Arora ji always tells. And for me today, I learned one important point from this, in my perspective, as a signature analysis. Because it's a challenging situation for the industry or establishment due to continuous frequent fire. Why can't we have the signature analysis for the series arc fault? Because series arc fault are not analyzed, not protected, except the arc plus AFDDs that can be used up to 63 amps only. Why can't we have the interactive approach of these people to have the signature analysis for the monitoring of healthiness of the installation? I hope Rajesh Arora ji will initiate something on this.
Yes, sir. Point well taken, and I have noted it down. And definitely, I will bring some experts on that field, and we will start doing R&D on that part also.
Thank you.
There will be some session on that part also.
Thank you, Arora ji and Mandar ji. My special appreciation and congrats to you.
Thank you, sir. Thank you once again. Sir, I have a few questions from my side, then I will invite some questions from the participant.
Yes.
In the slides, you have mentioned that there are some tests for the interrupter, some tests are for driving mechanism, testing control unit. These all tests are as per IC 62271-100, very true. But in your slides, the testings of control unit was missing. Why didn't you cover that thing? I just want to know that thing.
What, sir? Sorry, sir.
Testings of control unit, including coil current, coil voltage, auxiliary contact timing, that was not in the slides you show. You have already
It was available, sir.
But I think that measurement of the auxiliary contact timing was not there anywhere in the slide.
Auxiliary contact timing was not there, sir, because the timing principle is simple. Just I want to highlight here is that whenever we are performing the timing test, suppose that timing test of auxiliary contact or the contacts, interrupting contacts, then in that case, what happens is that we are just simply applying the voltage to the contacts at the one point and we are sensing at other point. In auxiliary contact, particularly there are two types of the contact. First one is the dry contact and second one is the wet contact. Okay. Dry is basically the potential contacts where, with the help of which we can able to identify the status of the CV. Likewise, the contacts which we are giving to the our PLC SCADA for the indication purpose only. And the wet contacts are basically coming in series with your coil for the protection purpose. Okay. So whenever we are performing the operation on the weight contact, we are taking the cognizance or we are taking the reference of your station DC or the station DC or AC that is dependent on the operation of the coil. And in case of the dry contacts, we are applying the potential from our kit itself, and we are sensing the make and break of the contacts.
Okay. Sir, can you stop sharing because I want others to be there on the screen?
Yes, sir. Yes, sir. Sorry, sir.
Okay. Now my next question is, you have talked about the pole discrepancies. True.
Yes, sir.
Sometimes all three poles are not touching or opening at the same time. Some discrepancy may be there. But
yes, sir.
What is the range of discrepancies allowed as per the IC 62271-100?
1.5 seconds.
1.5 seconds. Okay. In
yes,
case
sir.
that is more than that, can we adjust that timing or we have to change the pole?
No, actually, sir, pole discrepancy relay, that means suppose that when pole discrepancy relay comes into the picture, suppose that we are giving the command, common command to all the three poles. That is the R pole, Y pole, and B pole. Suppose that two of our pole are operative, properly operated, and one of our pole won't get operated. Then in that case, what happens is that pole discrepancy relay will wait up to 1.5 seconds, or whatever setting we are feeding to the pole discrepancy relay, it will wait up to that second, and after that immediately it will create the trigger.
I know. My question is, suppose there is a pole discrepancy of more than 3 seconds, 3 milliseconds. In that case, what step to be taken? What are the corrective action to be taken?
3 seconds or 3 milliseconds?
3 milliseconds. 3 milliseconds.
Sir, that is the difference between the, that means pole discrepancy. You are talking about the bounces or the difference between the two contacts. Suppose that you are having the T-shaped breaker. So I thought that it is the pole discrepancy relay.
No,
that's why I said 1.5 seconds. Because the timing for the pole discrepancy of two breaks is 2.5 seconds, whereas the pole to pole variation is only the 5 second allowable. If it is not in the specified limit, then in that case, we need to cross check the things.
What corrective action to be taken?
Corrective action first. Sorry?
Corrective action. What are the corrective action to be taken in that case?
First thing is that we need to check that whether the both the contacts are proper or not. First thing. Second thing is that during timing, we need to cross check that we are, see, this is the voltage application principle. We need to cross check that whether we have made the proper connection to the flange, because we are making the connection with the help of the crocodile. If there are the contacts are not firm, then in that case you are not getting the proper results. Unless you won't get the proper result, you cannot able to comment on the result. That is the thing.
Mandar, can I add one point?
Yeah.
Bhushan here.
Yeah.
Remember? Yeah, sir.
I know. You are from Siemens.
Yeah. For pole discrepancy relay, basically the control voltage supply is also important. If we are operating 3 coils and suppose for Y phase, there is no coil, no supply. So we have to take corrective action on supply side.
No, actually, sir is asking about, first I thought he's asking about the pole discrepancy relay, but now he's saying between the two breaks, particularly of one pole.
Yeah. So he's discussing about the mismatch, contact mismatch.
Yeah. He's discussing about particularly the contact mismatch.
As per IC for closing in India, it is 5 milliseconds and opening it is 3.3 milliseconds.
Yes, correct. And for the pole discrepancy or the difference between the,
it is 1.5 seconds.
One pole is 2.5 milliseconds.
Yeah. Some customers set it to 2.5 and some set to 1.5.
Correct. Thank you for the information. Now coming to the last question from my side, what is significance of the linkage ratio you have mentioned many times in your presentation?
This is very important that about the linkage ratio, because see that linkage ratio at the time of calculating the contact travel, in my presentation also I have highlighted that the fitment or the feeding of the linkage ratio plays the significant role, because your contact travel is nothing but the mechanism travel multiplied by the linkage ratio. Whenever you are placing the transducer on your mechanism is moving vertically and your linkages are horizontal. Okay, so how your linkages are moving, because linkages are responsible for make and break of your contacts. If your linkage is proper, then in that case your make and break is proper. And according to the feeding data of the linkage ratio, we are getting the contact travel, which we are comparing with the manufacturer specification.
How to get that data? Is it given by the OEM or we can measure it at site?
No, sir. That is given by the OEM only. CB OEM. Yes,
Now
sir.
I invite questions from all the participants. They can unmute one by one and ask the question. Questions are welcome.
Sir, Neeraj Singh, I'm Neeraj Singh. I wanted to know what is the significance of rebounds time if it is beyond the limits, how it can impact the circuit breaker performance. And another thing I wanted to add in the Rajesh Arora's question that CB timing in GIS, there is a special tool, we can adjust the timing of that breaker by that tool. If it is beyond the permissible limit, we can very well adjust that timing.
Yes, yes, that can be done. But for outdoor breaker, that is not possible, I think.
That is not possible, yes.
Sir, kindly answer the question.
Yes, sir. Yes, sir. Actually, in case of the rebound, that means whenever we are assessing the health of the this damping mechanism, at that time we are checking that whether the over travel is there or undershoot is there or rebound is there. At that time we are checking the things. In case of particularly, I don't want to take the name of the manufacturer. In case of the this CG, we are getting the value of the rebound. Hello.
Please continue, sir.
Yes. Yeah. There actually you are getting the value of the rebound. So whenever our expectation is that whenever we are taking out the energy, immediately once the energy breaker is open, our mechanism should get stabilized, and there should not be any ringing effect after the opening or whenever we are taking out the energy. But in some cases, in some of the breaker manufacturer cases, we are getting the ringing effect after the opening of the contacts. Okay, or opening of the mechanism. That is the thing.
Okay, sir. Okay, thank you.
Now, Sunil sir, kindly unmute and ask your question. You have raised your hand. Sir, kindly unmute.
Yes.
Okay.
Mandar sir, you have given a very nice presentation and
Thank
useful
you,
information. We were using the Scope DCRM kits, very good kits. One question is that for the different manufacturers of the breakers, whether we have to use the different types of the transducer. This
yes,
is
sir.
my
very valid question. Very valid question.
Yes, sir. Actually, sir, different manufacturer. Sir, your question is that for different manufacturers of the CB, you require to use the different transducer.
Yes.
Yes, actually, sir, you require to use the different for the different manufacturers of the CB. You are required to use the different type of the transducer. But in nowadays, in most of the cases, the CB mechanism is the spring operative, where the travel is the angular movement is there. At that time, with the help of the change in the adapter, you can with the help of the single transducer, by simply changing the adapter, you can able to get the travel traces of the different manufacturers CBs also, sir.
Where from these adapters are getting?
Sorry?
Where from these adapters will get?
From Scope.
Or we shall have to fabricate it?
No, sir. Actually, as one of the leading instrument manufacturer, we have already done a lot of exercise in the development of the travel transducer, sir. Well, only thing is that that means we are also providing along with the circuit travel transducer, we are providing the adapters too, sir. Okay. Only thing is that in case of the pneumatic breaker or the spring pneumatic mechanism where the travel is different, then in that case you are supposed to place the transducer, specific transducer, sir.
My last question is that what is the effect of PIR?
PIR is basically the pre-insertion resistance, 8 to 10 millisecond prior to your main contact. PIR comes into the picture. It is basically simply to control the inrush current passing through the line. PIR, normally the many failure occur because of the PIR. The thing is that whenever your line length is more than 100 kilometer, 80 to 100 kilometer, then in that case PIR comes into the picture. The significance of the PIR, that is the pre-insertion resistance to control the inrush current. That is the thing, sir.
So far, DTL experience is concerned, we have already removed all the pair in our system because they were getting troubles and failures, and we have finally decided to remove it.
Achha.
Still, for some breakers, we have got the our old breakers. Okay.
Yes.
Now, Gautam Chand Jainji, you have raised your hand. Any question from any participant? Kindly unmute and ask before we say thank you to.
Namaste, sir.
Yes, yes.
This is Harsh Singh from RRV, Rajasthan. I have some very basic questions.
Yes, sir.
Number one is, hello, Mandar.
Yes, sir. Yes, sir. You're audible, sir. Yeah, please go ahead, sir.
Why opening time is generally less than closing time of a circuit breaker?
Sir, opening is very, very critical because whenever there is a fault, actually it is expected that your breaker should not allow that fault to pass to your critical devices like transformer or the CT, because of that your opening time is always less, and it is I already highlighted that your opening time is always in the range of 15 to 35 millisecond only.
No. Is there some measurement technique that makes it that different? Say 17 millisecond is the opening time and 35 millisecond is the closing time. Is there due to some measurement mechanism, or it is due to the closing and opening mechanism?
No, sir. At the time of the tripping, we are just taking out the entire energy. So the operation is so fast. That's why you are getting the separation of the contact within the 15 to 20 milliseconds, sir, only. That is the thing only. That's why relatively the open time is, I already told you that, sir, what is the significance of the open timing? Because hello?
But Mandar, we have seen that the opening springs are generally very smaller than the closing springs.
Achha.
Yes, it is there in the circuit breaker. Any expert from that circuit breaker side can also join me.
Yeah. I will answer your questions, sir. Actually,
Yes.
opening spring is always smaller than your closing spring, because at the time of closing breaker, that closing energy required to close as well as charge your tripping spring, because there is no motor given to the tripping spring.
Okay, that means
and your first question, why it is less than in range of 20 to 35 milliseconds, because if you see our sinusoidal waveform of voltage, after every 10 milliseconds there is voltage peak. And if we are switching capacitor, and if we are providing breaker which is whose opening time is more than 40 milliseconds, means in a opening period we will get 2 peaks, and that 2 peaks per capacitor switching is very dangerous. That's why breaker should open either in a 1 cycle or 1.5 cycle. That's why it is in the range of 20 to 35 milliseconds.
Can I give my opinion, sir?
Yes, sir.
Yes, sir.
To the best of my knowledge, that what I know from theoretical side, whenever there is a opening of the contacts, there is a creation of the high voltage, which is called as the rate of rise of the wrist tracking voltage.
Yes,
and
RRRV, triple RV.
Before reaching that voltage, your contacts should open and the arc should be quenched. That should be the criteria that I think. Yes, Aurora, sir.
Absolutely okay, sir. Triple RV to be kept in mind while designing, and the IEC 62271-100 has also defined that value, and all type tests are performed as per that IEC only.
Yes, sir.
Now, Paritoshi sir, kindly unmute. It's time to listen from your side. What do you want to say?
Good evening, each and all. This is Paritosh Avasthi from Bhopal.
Yes, sir.
Madhya Pradesh. Gentlemen, I am dealing in 132 kV or 66 kV class as primary voltage and railway traction substations. So traction, we are having only 2-phase supply. Is there any significant precaution to be added or to be observed from your side for two-phase supply system? Will you please mention anything in addition to your normal procedures and things for three-phase supply system?
So though it is
please mention that.
Yes, sir. Yes, sir. Thank you for the question, sir. Though it is the two-phase system, sir, the analysis or the signature analysis or the parameters what I have briefed during my presentation, what we require to monitor are almost same, sir. That means there is no special precautions we require to take during the this, sir. Only thing is that if you are having the VCPs, which are particularly at the shop floor, there actually the analysis is a bit different, because there you need to take care of the holding coil too with your closing coil. That is the thing, sir. Apart from that, for the outdoor circuit breaker, the measurement methodologies what we are following for the railway CPs are the same, sir.
Okay, thank you. And now, Jerome sir, kindly unmute and we would like to see you now. Please, sir. Waiting for your question. Kindly switch on your camera. Welcome.
Hi, good evening, Dr. Rajesh.
Good evening.
Yeah, no, this was a very good presentation. I was not much into this, but I think I learned a lot, because these are some things that I have never been exposed to. But I think Mandar was very good in his explanation, and I think without knowing the subject, I understood the subject. Thank you very much for the wonderful session.
Thank you, sir. Thank you very much. And with that, time to say goodbye, and thank you to Mandar sir for this wonderful presentation and answering all the queries that came in the mind of participant. With that, thank you very much, and thank you everyone for sparing your valuable time. Thank you, and we will be back with new webinar with some another expert on another topic. Thank you, sir. Thank you, everyone.
Thank you very much, sir. Thank you for giving us the opportunity. On behalf of entire Scope technical team, I would like to thank you, sir. Thank you.
Thank you, sir.
Thank you, sir. Yeah.